Welcome to Module 11 of the Six Sigma Institute's Lean Six Sigma Certification Curriculum, which follows both the Council for Six Sigma Certification and the International Association for Six Sigma Certification bodies of knowledge. A full copy of the Council for Six Sigma Certification's Book of Knowledge can be downloaded from the course description section for free. In this module, we will be discussing the basics of the DMAIC and the DMADV methodologies. This module will take approximately 50 minutes to complete. At the end of this module, there will be a 5-question quiz on the topics discussed, which you can complete on your own at any time. You will also find several Six Sigma tools that you can download, including a DMAIC Toolkit selection matrix, a project outline template, both of which are Excel files. And after completing this module, you will be eligible to take the Yellow Belt certification exam. If you score a 70% or greater, then you will be issued both the Six Sigma Yellow Belt as well as the Lean Six Sigma Yellow Belt certification. One of the things that sets Six Sigma apart from some other quality improvement and management methodologies is a structured approach to every project. In this section, we will discuss DMAIC and DMADV. The major differences between DMAIC and DMADV are the goals the team sets and the outcomes of the completed project. In some ways, a DMADV project might feel like it has a more tangible outcome, but in reality, both methods are seeking to deliver better quality, better efficiency, more production, more profits, higher customer satisfaction, or some combination of these things. We will introduce each of the phases of both methods in this module. But first, let us take a look at some quick definitions of each phase as they relate to DMAIC versus DMADV. During a DMAIC project, the define phase is concerned with identifying the problem, defining requirements for the project, and setting goals for success. Requirements and goal setting might relate to a variety of factors and are dependent somewhat on guidance from the leadership team and expected budgets. And Six Sigma leaders can use various tools within the phase to create flexibility that allows for a variety of project types. In DMADV projects, the define phase is slightly more rigid. Teams also have to identify a problem and begin defining requirements, but requirements must be made with a change management environment. Sometimes organizations have a change management program already in place, which means Six Sigma teams must incorporate all requirements of that program into the DMADV phases. The team also works to define customer requirements to create a measuring stick to which the process development can be compared. The DMAIC measure phase is when teams use data to validate their assumptions about the process and the problem. Validation of the assumptions also merges into the analyze phase. The bulk of the measure phase is occupied with actually gathering data and formatting it in a way that it can be analyzed. Measuring can be one of the most difficult tasks in a Six Sigma project if data isn't already being captured. Teams might have to build tools to capture data, create queries for digital data, sift through enormous amounts of data to find relevant information, or capture data by hand in some manual processes. After validating assumptions from the define stage with actual data, the team might revisit problem statements, goals, and other process-related definitions. Teams also work to measure key inputs and steps in the process in preparation for define. Teams work through a DMADV approach might do some of the same things during the measure phase, but activities are typically more targeted towards creating the new process rather than correcting the current process. During the analyze phase of a DMAIC project, teams develop hypotheses about causal relationships between inputs and outputs and between X's and Y's. They narrow causation down to the vital few, course, using methods such as the Pareto principle. And they use statistical analysis and data to validate the hypotheses and assumptions they have made so far. The analyze phase tends to flow into the improve phase in a DMAIC project. Hypothesis testing to validate assumptions and possible solutions might begin in the analyze and continue into the improve phase. A team using the DMADV method might also identify cause and effect relationships, but they are usually more concerned with identifying best practices and benchmarks by which to measure and design the new process. Teams might also begin to process design work by identifying value and non value added activities, locating areas where bottlenecks or errors are likely to occur, and refining requirements to better meet the needs and goals of the project. Six Sigma teams start developing the ideas that begin in the analyze phase during the improve phase of a project. They use statistics and real world observation to test hypotheses and solutions. Hypothesis testing actually begins in the analyze phase, but it is continued during the improve phase as teams select solutions and begin to implement them. Teams also work to standardize solutions in preparation for rolling improved processes into daily production and non-team employees. Teams also start measuring results and lay the foundation for controls that will be built in the last phase. The fourth phase is where the DMADV project begins to diverge substantially from DMAIC projects. The team actually works to design a new process, which does involve some of the solutions testing mentioned above, but also involves mapping workflow principles and actively building new infrastructures. That might mean putting new equipment in place, hiring and training new employees, or developing new software solutions. Teams also start to implement the new systems and processes during the fourth phase. For DMAC and DMADV teams, the control or verify phase is where loose ends are tied and the project is transitioned to a daily work environment. Controls and standards are established so that improvements can be maintained, but the responsibility for those improvements is transitioned to the process owner. During the transition, the Six Sigma team will meet with subject matter experts and trainers in order to update the standard operating procedures and integrate them into the training offered. They might even work with the process owner and his or her department to troubleshoot any problems with the improvement. A business wants to create a smartphone app to help customers make and manage appointments. The team handling the improvement would choose a DMADV approach. They are creating a product that doesn't yet exist, while the team is meeting a need that already exists and is improving an overall process, the setting of appointments. The app itself is a new process and a new product. The app will need to be designed, integrated into existing systems, and the final product tested before full implementation. A company that manufactures pizza boxes isn't happy with the profit margins in the small size boxes. This is a classic example of what brings many teams to the DMAIC method. The problem hasn't yet been defined, but the organization knows that goals and expectations are not being met. A leadership team might work with subject matter experts and one or more Six Sigma experts to discover more about the processes involved before settling on one or more improvement goals. During the define phase of a Six Sigma process improvement project, teams create what is known as a project charter and a basic plan for work. A charter is a synopsis of the project. It provides some common information and a summary of what the team hopes to accomplish. The charter usually features a list of team members, names of those responsible for outcomes, a problem statement, a goal, and some basic definitions of scope and metrics for success. Some charters also include a rough timeline estimate for the project. Also, during the define phase, teams create or list measurable customer requirements and create high level documents about the process. Often, Teams will create a SIPOC diagram to help them understand a process. Teams should also identify stakeholders. Stakeholders are individuals, both within and without an organization, who have some level of influence on the success of an improvement project. By understanding who stakeholders are, teams can remain in contact with various persons throughout the project. One of the biggest challenges Six Sigma teams face when in the define phase of the project is generating positive, targeted momentum that sets the foundation for the rest of the project. As a Six Sigma team leader, you can increase the chances of success by keeping the team as focused as possible during the define phase. Begin by explaining the Six Sigma process and the purpose of the project for any ancillary team members who may not be familiar with Six Sigma and DMAIC. Next, work as a team to create ground rules for how the project will run, including how meetings are organized and managed, how information will be communicated, and what each team member might be responsible for during the project. Create a charter and a project plan so the team has something to focus on. If possible, have the champion of the project spend time with the team. Hearing directly from an executive leader about expectations and the support of leadership for the project helps to motivate a team. At the same time, ensure the champion doesn't step in to take over the project as this isn't his or her role. Once a team has a good grasp of what the process does and how it works, what the problem is, and what the goals for the project are, the team moves from define to measure. The transition between phases is marked by a toll gate review, wherein the team presents its work to a champion. The champion provides feedback and makes the decision about whether the team is ready to move on to the measure phase. During the measure phase, the team is concerned with creating a baseline metric for the process and refining problem statements and other outputs of the define phase. Creating a baseline metric lets teams understand how a process should be measured and how the process is really performing before improvements begin. It also provides a comparison point so teams can show how much an improvement they have brought to the project. A successful measure phase requires strong observational skills and understanding of the reasons behind the measure, knowledge of the data types, such as discrete and continuous, tools for measurement assessment, and a strong background in statistical analysis. The measure phase is often the most challenging phase for a Six Sigma team leader, especially when working with teams that are inexperienced. When teams start to really dig deep into a process and begin to measure things, they often get a true idea about how challenging the problem really is. They might also have a difficult time understanding how and when to measure things, and collecting data that hasn't been collected before can be time consuming and tedious. Because of all of these challenges, teams might enter what is called a storming stage. Team members question the viability of the project, complain how much time the project is taking from other duties, or stop showing up to meetings altogether. Six Sigma leaders can reduce the impact of storming by demonstrating a calm approach to each aspect of the project and redirecting the strong emotion of storming to more productive work. If you can identify an easy task or problem, letting the team work on that and accomplishing something immediately can reduce the excitement of storming. Once measurements are collected, Six Sigma teams usually move on to the analyze phase. Again, a toll gate review is conducted between phases, but the lines between measure and analyze are often blurry. In some cases, a team has to measure, analyze, and then measure some more, particularly if metrics aren't already in place for a process. Analyze phases are when teams perform detective work on the process using the clues gathered during the define and measure phases, along with information provided by the process owner and subject matter experts. Teams attempt to identify root causes for a problem. They use statistical analysis and other tools to verify causes before turning the work of identifying possible solutions. During the analyze phase, teams use a variety of tools. Tools common to the analyze phase includes Pareto charts, run charts, histograms, cause and effect diagrams, scatter diagrams, process maps, and of course, value analysis. Teams in the analyze phase might continue to suffer from storming. If teams didn't storm during the define or measure phases, they might begin to do so in analyze. Six Sigma leaders can use the same tips for controlling storming in the measure phase in the analyze phase. Another common challenge for Six Sigma team leaders is introducing and explaining statistical concepts during the analyze phase. When other team members or even the champion of the process are not familiar with statistical analysis, presenting advanced analysis in terms of statistical verbiage can only be a mistake. Team members won't understand how you came to the conclusion you are presenting, which makes it less likely they will get behind the solution or improvement in a positive way. Six Sigma experts should be aware of the knowledge limitations of various team members and work to both present information in a way that is understood by everyone and continue to use team member knowledge by explaining concepts when possible. During the improve phase of a project, a Six Sigma team selects a final solution and begins to put it in place. Sometimes, teams will select more than one solution, especially if a few smaller solutions are highly related and work together for an overall solution. It is best practice to implement one change at a time and verify that change before moving on to something else. If teams also come up with many possible solutions, they should use a solution selection matrix to evaluate solutions, choosing only the best solutions for the project. But the best solution is not always the solution that provides the most improvement. Solutions that are so expensive or disruptive that they cause disadvantages that outweigh any benefits should never be selected by project teams. During Improve, Six Sigma teams must continue to keep the project definitions in mind. The solution must address the root cause verified in the analyze phase. The root cause must be directly related to the problem stated during the define phase. Possibly, the most common problem that plagues Six Sigma teams during the improve phase is project fatigue. By the time the teams come to improve, they have been working on a project for weeks or even months. For many team members, the project work is on top of their regular work. Fatigue or frustration might push team members to select and implement solutions just to have the project completed. Six Sigma leaders have to work to keep teams motivated on quality and improvement. The best way for a Six Sigma team leader to create strength as the team nears project completion is to build a good foundation in the earlier phases. Teams that understand the DMAIC process and have a basic understanding of Six Sigma and statistical analysis are more likely to stick with planning, analysis, and the DMAIC method. Six Sigma team leaders should also continue to foster a team-based approach to all aspects of the project. One challenge for some leaders is the temptation to take measurements and analysis and begin performing much of the work themselves, but doing so alienates team members. Control is the final phase for Six Sigma teams. During the control phase, teams usually handle four tasks: creating the foundation for process discipline, finalizing documents regarding the improvement, establishing ongoing metrics to evaluate the process, and of course, building a process management plan that lets the team transition the improvement to the process owner. Tools used by a team during the control phase include documentation checklists, control charts, response plans, process maps, and process dashboards. The control phase is often easy for a team because the work of the team has already reached a crescendo. In a well-run DMAC process, the control phase is a time of wrapping up loose ends and arriving at the end of a project. At the same time, teams might find it challenging to let go of a process they have put so much time and effort into. Six Sigma leaders can help team members transition a project by preparing them in advance for this phase. You might also find ways to incorporate team members into meetings or presentations where project results are being shared. Six Sigma leaders should always host a meeting to wrap up the project. The meeting should be somewhat celebratory in nature, if budget, time, and policy allows. Six Sigma leaders might consider having lunch or snacks at the meeting. Take time to recognize each team member's contribution and ask team members to identify something they learned that can be applied to their own work. This helps team members see that Six Sigma is an ongoing culture within an organization, and the end of our particular project doesn't equate to the end of each person's involvement in continuous improvement. Recognition is extremely important when ending a Six Sigma project. Team members might have put in extra hours to provide excellent work on a project while maintaining their own regular responsibilities. Design is the fourth phase of the DMADV process. It replaces the improved phase of DMAIC. DMADV is one approach for what is called Design for Six Sigma or DFSS. Another approach is called DMADOV, which stands for Define, Measure, Analyze, Design, Optimize, and Validate. Teams using DMADV approach usually combine the activities from design and optimize. The design phase of DMADV is when teams create a new process or develop a new product. A Six Sigma team would have previously done all the work to lay the foundation for development during define, measure, and analyze stages, which means most of the design phase is taken up with actual work involved in creating the process or project. Using the plans, instructions, or maps created in earlier phases, the team either creates a product themselves or works with vendors, manufacturers, or other employees to create the product. During design, a team will also test the product, process, or service. Testing can be done in testing environments, in limited production environments, or via beta testing. In a process redesign project, all phases are essential, but design is often seen as the most critical. Teams that falter in the design phase can waste the work that was put into other phases, and it's easy for teams to fall prey to project fatigue just as work requirements pick up for everyone involved. Six Sigma team leaders can help improve the chances of success by following the tips for managing improved phases. Teams should also be realistic about target dates for design work. Promising a complete solution in a short time period pleases leadership at first, but if teams are rushed, they tend to deliver low quality processes. If you promise a too good to be true timeline, you also run the risk of running far behind schedule, which can impede the work of other projects and process improvements. The verify phase of a DMADV project is very similar to the control phase of a DMAIC project. The new process, product, or service is transitioned out of the project mode and handed off to a process owner or employees who will work daily with the process or product in question. Control plans, including control charts, might be put in place by the team to track ongoing results, and almost all of the tools used in a DMAC control phase are relevant to verify. One of the differences between verify and control is that DMADV teams might take time to complete further critical to quality analysis at the end of the project. This is so they can identify new critical to quality factors. This is done because the process or product is different than it was when the team first started working. A new process might have a capability the old one did not. Having that capability, the customer might decide it is most important factor in quality about the process or product. At the end of the verify phase, a team delivers a final product or process that meets the needs first identified in the define phase. One of the major differences between DMAC and DMADV is the possible timeline. We previously stated that a problem fits the DMAC model if it can be solved in less than 6 months. While some DMADV projects might only take a few months, Many process or product designs can take years. Because of this, the concluding challenges for a DMADV team are similar to those in a DMAC environment, but they might be heightened by the length of time a team has spent on the project. Team members who have spent a year or more working to develop a new process or product might feel like the end of the project threatens their job. This is especially true when team members have not been handling regular work duties in addition to product duties. Six Sigma leaders and champions can reduce these worries by communicating next steps and expectations clearly with the staff. Six Sigma team leaders should ensure that a DMADV project closes on a positive note by validating all team members and ensuring process owners have all the tools they need to accept the new process without disrupting the work. You should now have a basic understanding of how a Six Sigma team approaches a problem or process improvement, whether improving an existing process or creating a new process or product. Teams work through phased approaches. The phases of DMAC and DMADV provide control and organization for a project, help keep everyone on task, and let teams break up what can seem like enormous tasks into chunks that are tolerable. As the old adage says, how do you eat an elephant? Well, one bite at a time. Similarly, the phased approach of Six Sigma breaks up the elephant so that teams can work on it one small bite at a time.